Hi there. Today's lesson is on rational numbers. Now, we talked about integers the other day. Today, we're going to talk about rational numbers. So we're going to refresh our memory with this warm-up. I want you to figure out which number is an integer. Is it A, 345 thousandths? Is it B, 1/2? Or is it C, 34? I'm going to give you just a little bit of time to think about which one of those numbers is an integer. Okay, so if you picked C, you are correct. C is a whole number, 34. And if you think back when we talked about integers, you would know that the integers are the set of numbers that we count by. 1, 2, 3, 4, 5, all the way to infinity. So today we're going to talk about rational numbers. But we're not just going to talk about them, we're going to actually graph them. But first we need to look at our learning targets. The first learning target is, I can represent a rational number as a point on a number line. And our second learning target is, I can graph a rational number on a number line. But before we can even talk about rational numbers, we need to figure out what they are. So I want you to take just a quick minute and we're going to watch this video and then we're going to come right back and we're going to talk about rational numbers.
All of us know what a number line is, and the numbers we see here on the number line are called integers. On the right side of 0, we have positive integers, and on its left, we have negative integers. Integers we are familiar with, but what about numbers like these? 1/3, 5/6, or -7/12? Each of these are numbers, but we don't use them as often as we use counting numbers. Such numbers are called rational numbers. But we need to define them well. We cannot say numbers like these are rational numbers. We say that they are of the form p/q. One number in the numerator and one in the denominator. But there are a few conditions we need to know. P and Q should be integers. We can have only integers in place of P and Q. And there is another important condition. Q should not be equal to 0. Why do we have the second condition? Say I ask you to calculate 3 divided by 0. What would be the quotient? 0 multiplied by what will give you 3? There is no such number. This value is undefined. So this is the basic definition of rational numbers. It is a number of the form p/q, where p and q are integers and q is not equal to 0. There are many questions that should pop up in your head when you see this definition. What is the difference between rational numbers and fractions? Are integers classified as rational numbers? What about 0? How do we plot such numbers on a number line? And how do we compare two rational numbers? For example, if you're asked to compare 1 and 5, you could easily say that 5 is greater of the 2. But what if you're asked to compare numbers like 6/7 and 13/15? How would you find out which one is greater? Don't worry about it. All these questions will be answered in our videos on rational numbers.
Okay, as you can see from that video, we learned a couple of things. A rational number is a number that can be written as a fraction, but where the denominator is not 0. Now the video showed you why it can't be 0, because you cannot divide by 0. That is undefined. So when you cannot have a 0 in the denominator. Okay? But rational numbers also include whole numbers, decimals, and fractions. But let's think about this a while. Wait a minute, you said whole numbers were integers. Well, but they're also rational numbers because we can write a whole number as a fraction by just putting it over 1. Bingo. fraction. All right? Decimal numbers, if you say them the correct way, so we're going to say 0.3. How do you say that decimal the correct way? Well, we say 3/10. Bingo! Again, we just write the fraction 3/10. So, whole numbers, decimals, and any fraction you can think of are rational numbers. Okay, these are all rational numbers. So now let's do some work with them. On the number line, when you look at a number line, we looked at this the other day, not all the tick marks are marked. Okay, the major tick marks maybe, but the ones in between are not. You need to figure out how many tick marks are in between each whole number. That will tell you what fraction of the whole is each tick mark. So on this particular number line, if we go from 0 to 1, we see that there's 4 tick marks. We have to do 4 bunny hops. 1, 2, 3, 4 between 0 and 1. So that tells us that each one of these tick marks is 1/4 of the way to the number 1. Okay, 1/4, 2/4, 3/4, 4/4. And remember, 4/4 is the same as 1. Okay, 4/4 is the same as 1 whole. All right? So just remember that. So let's look at you have to decide the integers. Well, let's look at point A. Point A is on the second tick mark. Here's the first one. That's 1. And here's 1/4. So this point is between 1 and 2. It's at 1 and 1/4. That would be explained here. You can go ahead and stop the video if you want and read the explanation here. So now let's try some. The first problem that we're going to do together says select the locations on the number line to plot the points 9/2 and -7/2. First of all, we're going to look at this number line. There's -5 and a whole bunch of marks here and a +5. I don't even know where 0 is. So you know what I'm going to do? I'm going to count back from 5 to 0 to figure out where I put my 0. All right, so we have 1 bunny hop, 1, that's 4, 3, 2, 1, 0. I believe our 0 is going to be right here. So that makes it a little bit easier. We know that that is 0. Now, there's how many tick marks in between our big ones? This would be 1. This is 2. Remember, as we go to the right, the numbers get bigger and they're positive. As we go to the left, our numbers are negative. -1, -2, -3, -4, and -5. So the numbers between 0 and 1, there's 1 tick mark in there. That breaks that space up into exactly 1/2. So each one of these tick marks is 1/2. So as we go to the right, it would be 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. Okay, so now we have our number line number line marked. So we did the first thing. We figured out our tick marks. Now we have to figure out where we're going to put these, where we're going to graph these. So you can leave these as improper fractions. You see that the numerator is bigger than the denominator? That means it's an improper fraction. We like to get mad at those, don't we? But we don't have to be mad at them today. We can go ahead and count 9 halves because we know that each one of these tick marks is a half. We just have to count 9 of them. So I'm going to take my pen and I'm going to do some bunny hops because I like bunny hops. We're going to start at 0. And we're going to count 9 halves. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to land right there with 9 halves. Easy peasy, right? What about negative 7 halves? Well, we know that it's a negative number, so we have to go the other way on the number line. But we always have to start right here at 0. Always start at 0. So let's count 7 bunny hops. 1, 2, 3, 4, 5, 6, 7. We're going to land right here with negative 7 halves. Okay? So, if they are the same denominator, you can just leave them as improper fractions. And this one was 9 halves. 9 halves. So there we go. We just plotted our 2 points on our number line. So let's look at this one. This number line shows 4 points. A, B, C, and D. Which point is at 1 3/4? Negative 1 3/4. So it has to be one of those numbers, A, B, C, or D, because all the numbers to the left of 0 are negative. But let's see. What do our tick marks represent? I'm going to do this over on the positive side, but it'll be the same on the negative side. So there's 1 bunny hop, 2 bunny hops, 3 bunny hops, 4 bunny hops, 4 bunny hops. So that means each one of these tick marks represents 1/4. 1/4. 1/4. And 1/4. It's the same on the negative side as it is on the positive side. So let's look at this number again. Negative 1 3/4. So we're going to take our bunny hop. I'm going to use red. We're going to take our bunny hops and we're going to go one whole big bunny hop to the negative 1. And we already know that each one of those little tick marks is worth 1/4. So we're just going to count 3 of them from here. 1, 2, 3. So point A represents negative 1 3/4. Guess what? Time for you to practice. I want you to go ahead and log into IXL. You are going to work on the teacher suggestion called Rational Numbers on a Number Line. It's quick code is DJE. So I don't want you to stress over this. I just want you to work for 10 minutes or until you get 10 problems right. Okay, so this is what it's going to look like when you start practicing in IXL. It's going to ask you to graph negative 0.75, 75 hundredths. All right, we know that negative 1 is here and 0 is here. So we know it's got to be on this side of the number line because everything on the left is negative. Again, 75. So if I write that as a fraction, 75 100ths, you can think of that as 75 cents out of $1. Or wait a minute, would that be like 3/4? It would be 3/4. So I would just, each one of these tick marks, let's think about this. Here's 1 bunny hop, 2 bunny hops, 3 bunny hops, 4 bunny hops. Just so happens that our number line is got 4 tick marks between 0 and -1. So I'm just going to have to count 3. So I'm going to go 1, 2, oh no wait, 1, 2, 3, and I'm going to put my mark right there. And I'm going to submit it. Excellent job. Okay, oh, this might be a little harder. Now, did you notice up here, oh my goodness, did you notice up here that you can watch a tutorial on this? Let me go back real quick. Oh boy, we'll go to here. Okay, it says learn with an example. You can watch a video and it will explain to you on a number line. If you get stuck, you can always go watch this video right here. All right, so just practice and do your very best. Don't stress, and have a great day.